Okay, so now we're going to do linear models. Linear models just means application questions. So what you're going to see now is they're not going to call it the gradient. The gradient will be mentioned in some other way. So other words that trigger you to know that that's the gradient is you'll see, yeah, good, they might say slope. You'll see the rate. So the rate that something's changing, that is the gradient. Or you might see the other times you see the word per, you'll know. Because if something's changing per this, that's a gradient. All right, so linear models. And then if you're talking about the y-intercept, because that's when x equals 0, yeah, that's often the case of when it initially starts, yeah? It's like often when it's got time, it's the initial, oh my God, I can't spell. How do you spell initial? Yeah, initial thing, yeah? So that's what you sort of got to think when you're doing practical stuff. So let's have a look and read through the question. So remember those sort of things. So Auscom's rate for local calls from a private phone consists of a quarterly fee of $40 and plus 25 cents for every call. Could I say it as 25 cents per call?
Yeah.
So see how I used the word per? So what do you think that's telling me that is? That's the gradient. So we don't like to talk in cents, but particularly when they've used dollars here. So I'm going to change that. Because that's 25 cents, I'm going to say that's the gradient because it's like a rate. And this is the one-off fee. So even if you don't make any calls, so no calls, so maybe, like, could you say x equals 0? Yes? I've got to pay $40. So what's that $40? Yeah, so that $40 is the y-intercept. So construct a cost function. So function just means rule, and they want a cost. So I'm just call it C equals, and normally we say the gradient, don't we? So I could say 0.25 n for the number of calls plus 40. And I'll just write that, all right, C equals the cost in dollars and n equals the number of calls. Just test it out so you know. If I make 0 calls, I've still got to pay $40, don't I? Yeah? And then so on. Okay? So, I think I've just added this little statement in here to help you. So an important linear relation is a relationship between distance and time travel. So what they say, they often have these as graphs. So often it's distance and over time, yeah? And sometimes they don't like to use the letter D in distance because anyone doing physics and that, we like, isn't displacement an S? The symbol? Oh, anyway, S is often used for a distance. It's like a displacement that you've moved, yeah? But it doesn't matter. You can always just think distance over time. And so obviously you go like this, and the gradient of a distance time graph, so the gradient of a distance time is often speed. Yeah, is a speed you're travelling. So gradient of distance time equals speed of the object, yeah? And those doing physics, what's the gradient of the velocity versus time? Do you know what that is? What's V over T? Formula for? Acceleration?
Acceleration.
Yeah, so there. So whoever's doing physics, you're failing. No. It's joking. All right, let's keep going. Let's do this one. So remember, so that was one way of getting a graph in terms of they gave me the gradient and they also gave me the y-intercept so I could set up the formula. What's another way of obtaining the formula? We were talking it over there. What did I say you had to have if you want to get the whole formula? What do you have to have if you want to get 2 points? 2 points, good. So sometimes in these worded problems, they're actually giving you 2 points without you knowing. So the tyres of a racing car lost 3 millimetres tread after completing 250 kilometres of a race, and then it lost 4 millimetres after completing 1,000 kilometres. Assuming the loss of tread was proportional to the distance covered. So they're just saying, assuming that the tread is only getting lost because of the distance travel. We know that isn't the case in real life, but that's why they write that, because some nerderoid's going to argue, wow, blah, 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 blah. Yeah. So that's eliminating that fact. So it says find the total loss of tread. So when you are asked to find like the total loss, that's generally what your equation wants to be. So they want your equation to be D equals. So that's the loss, yeah, the tread loss. So they want D equals, and that's the millimetres tread loss. And after S kilometres. So S over here, kilometres is going to be in your graph. So can you see, I got given, if that's D, that's like my Y, isn't it? Because I'm going to say it equals. Obviously, we're doing linear models. And that's like my X. So can you see up here, I've been given a Y value, which is 3, and an X, which is 250. Write this point like this. Are you happy with that? Yeah. And then the other point, how could I write that one? It would be 1,004. Because we want to put the X first, don't we? Yeah? So why did I do that? So I can use my gradient formula. Yes, to find the gradient.
Yeah.
So I'm going to do, this is where I had to have the right, I had to have it in the right way, otherwise I'll get the wrong thing, won't I? So I get 1 over negative, so it's a negative gradient, yep. Yep. So that makes sense. The more K's you do, the less tread you've got on your tyre. Or, no, I did it right. X2, there's my X2, minus, yeah.
Who said that's wrong?
Oh, it's positive, you mean? Yeah. Sorry. Yeah, that's right.
Well, that's right.
Yeah, it should be positive, sorry.
Positive. Yeah.
Positive. So, I've got D equals 1,750x, but we've still got plus C, yeah? So how am I going to find C? Just use any of the points. I'll use the first one. Yeah? So 250 equals... Oh, sorry. I've done that wrong. 3 equals 250 over 750. Yeah? Plus C. So that's 3 equals 1 over 3. Yeah? Sorry, running out of room. So 3 minus a third equals C. 3 would be 9/3, minus 1 is 8/3. Are you happy with that? I'm doing that fraction stuff in my head and a lot quicker. Can you see how you need to know fractions? I changed that to thirds. That's like 9 over 3, isn't it? Yes? No, you need to be like that. So your distance is actually 1 over 750 plus x, s, yeah, good, s plus 8 over 3. Yeah? And that's fine.
Yes.
Leave it like that.
Okay.
Alright, a car starts from point A on a highway 10 kilometres past the Wangaratta post office. Didn't I?